Okay, welcome to the review session for Quiz 12, which is over Unit 4, Chapters 15 and 16, Game Theory and Monopolistic Competition. As I said in class, there are three types of problems that you're going to see on this quiz, or three concepts, I guess, three major concepts. One is the duopoly analysis, where you're given the table and say if these two firms split the market, how will they do it, how much profits will they make, and then usually what if one of them cheats. So we'll do one of those problems. Another is the kind of problem that is a game theory payoff matrix kind of situation, where two firms or two parties in the situation, whatever it may be, are dealing with different options, and then it gives you the payoffs, the profits from them. And then problems with monopolistic competition, where you're dealing with a firm that's in a monopolistically competitive scenario and usually having to deal with a graph and interpret the graph of what's going on in both the short run and long run. So let's start with the duopoly analysis. This comes straight from the multiple choice practice problems from chapter 15. It's the first table on there. Demand for crude oil given in terms of its quantity and price, and then total revenue is given, which basically already does the calculation of quantity times price for us, so that's nice. And the problem asks, the accompanying table shows the demand schedule for crude oil. For simplicity, assume the cost of producing crude oil is zero. In other words, the marginal cost of crude oil equals zero. Suppose the crude oil industry is a duopoly. Two firms collude to share the market equally. Two firms are owned by Laverne and Shirley. Silly. In this case, the price of crude oil will be how much will Laverne and Shirley each produce, and how much will their profits be. So, to get at this, we're going to first just take the same kind of thing we do with a monopoly. We're basically saying if this were a monopoly industry, what would their price and quantity be? So we have total revenue, we need to find marginal revenue. And since the quantity changes by 10 each time, we're going to divide the change in total revenue by that change in quantity of 10. So 1,500 divided by 10 is 150. The difference between these revenues, 1,500 and 2,800, that's 1,300 divided by 10 is 130, and so on. You're going to see the pattern pretty quickly. 90, 70, 50, 30, 10, negative 10, negative 30, negative 50, and let's stop there. So first, if the marginal cost, as it says in the problem, is zero, then we're just looking for the last quantity where marginal revenue is greater than marginal cost, which in this problem is another way of saying we're looking for the last quantity where marginal revenue is positive. So that is here with a quantity of 80 and a price of 80. So the problem asks us what happens if Laverne and Shirley split the market, produce a price, produce at a quantity and price that a monopolist would produce at. And so use L for Laverne. Laverne would have a quantity of 40, half of that 80. Price for that would be 80. And so the profit, which is total revenue minus total cost, is 40 units times $80. So $3,200 minus total cost of zero, which again, for simplicity, they've said the marginal cost is zero, so the total cost is also zero in this problem, since they haven't said there's a fixed cost. Not realistic, but that's just for simplicity of the analysis. And then Shirley would be, since they're splitting the market, they're going to have the exact same thing. We don't really need to go through the calculation. The profit for both of these is 3,200. So quantity of 40, price of 80 each, profit of 3,200. Now if they ask, and often these problems do ask, even though this one doesn't, what happens if Laverne or Shirley cheated on the agreement? It would usually say something like, what if Laverne chooses to produce 10 more units? What happens then? So Laverne's new quantity is 50, and the price now, since Shirley's still producing 40, Laverne's now producing 50. Now we've got 90 units, and we have to sell those, we have to drop the price to $70. So the price is 70. Notice that our profit, 3,500 minus 0, is 3,500. Laverne's made herself better off by cheating, by producing more. Even though the price is down, she's producing enough more that her profit goes up from 3,200 to 3,500. Shirley's much worse off. She's still only selling 40 units, but now she's got to drop the price of it to 70, and so she's making $2,800 in profit. So what this is showing is that Laverne or Shirley, if Shirley were the cheater, either one of them has an incentive to cheat on their agreement, which makes the agreement hard to sustain without any kind of binding agreement, which the U.S. law makes illegal. So there's a typical addition to this kind of problem is what happens if one of them cheats. So the key to remember there again is once you increase the quantity, make sure to decrease the market price that you've got to set to sell that new quantity. Okay, there's the first one. Moving along to the game theory problem. So in this problem, this is the second one on that free response question that was handout that was in your AMDG Google Drive folder. 2 airline companies, AirTouch and Windward, operate a route from city X to city Y, etc., etc. Payoff matrix. The first cell, as always in these, is the one on the left. First cell is AirTouch. The first number in the cell is AirTouch. The second number in the cell is Windward. So just like the one we saw yesterday, in what market structure do these firms operate? The market is an oligopoly market. We know that because there are just 2 firms. B, if Windward chooses an evening departure, which departure is better for AirTouch? So if Windward chooses evening, that means AirTouch's options, you could say, are earning either $700 or $900. So evening is better for AirTouch. That question is just a matter of making sure you know how to interpret the table. Then identify the dominant strategy for Windward. So Windward's dominant strategy, we start with looking at what if AirTouch goes morning. Then Windward is looking at either 700 or 600. So it would rather have 700. If AirTouch goes evening, Windward is looking for 950 or 800. So it wants 950. Therefore, since these are both in the same category for Windward, morning is the dominant strategy for Windward. D is choosing an evening departure, a dominant strategy for AirTouch, and explain. So a very similar one to this yesterday. So for AirTouch, we're looking at, is evening a dominant strategy? Probably the best way, again, is to kind of go in reverse and say, okay, if Windward chooses morning, then AirTouch is better off going morning, which already tells you evening is not their dominant strategy, but let's keep going, play it out. If Windward chooses evening, then AirTouch's best option is evening also. So the answer is no, and AirTouch does not have a dominant strategy. There is no one choice that's better off no matter what. I'm not going to write that whole thing out, but that's the answer. The reason is they don't have a dominant strategy because there's no one choice they can make that makes them better off no matter what. And lastly, if both firms know all of the information in the payoff matrix but do not cooperate, what will be Windward's daily profit? So since we know that Windward has a dominant strategy of morning, that's kind of the main thing we know here is that Windward's going to go morning. And Windward knows that, and AirTouch should know that, since they both know all the information in the payoff matrix. So if AirTouch knows that Windward's going to go morning, then, again, we already said that their better option is morning in that case. So AirTouch will also go morning, and it asks what will be Windward's daily profit, which is that, when we're choosing that combination. The answer is $700. All right, and lastly, here's a problem with monopolistic competition. Mary & Company, operating in a monopolistically competitive industry, produces a cleaning product called Bright Clean. The company currently produces the profit-maximizing quantity of Bright Clean, but is operating at a loss. Draw the graph and show the profit-maximizing output and price. Oops. Labeled PM and QM, and the area of loss shaded. So we go with our standard monopolistic competition graph, whether they're making profits or losses, starts with this: price, quantity, demand, marginal revenue, and marginal cost. And we can also identify MC equals MR gives us our profit maximizing quantity. Extend that up to the demand curve and over for the profit maximizing price. And they wanted us to label those PM and QM. And then if they are losing money, that means we need to put the ATC way above this point here. So we'll draw ATC up here, try to get it to cut through the marginal cost curve at about its minimum point. And our area of loss is going to go from this highlighted point, again, the point on the demand curve where they're operating, up to the ATC and over, and shade that area in. There's our area of loss. So that's part A. Next, part B. What must be true in the short run for the company to continue to produce at a loss? So we know this from perfect competition. What we learned a few chapters back is that the price must be greater than their average variable cost, or their loss must be less than their fixed cost, FC. Even though we're not talking about perfect competition here, those concepts would still apply. The firm is still going to want to make up at least some of its fixed cost. So, same idea. Part C. Assume now the demand for cleaning products increases. The company is now earning short-run economic profits. Relative to this initial situation, how does each of the following change, or I'm sorry, relative to the new situation where they're earning profits, that's this short-run situation, how does each of the following change in the long run? So when we're going from profits to then the long-run transition, how does the number of firms change? That's the easy part. If we have profits, we know that more firms enter. So the number of firms increases. Because in monopolistic competition, free entry and exit draws in new firms when profits are being made. And then second, what happens to the company's profit? The other thing we know about what happens over the long run in monopolistic competition is that the profits get competed away because the individual company's demand falls for its product, and its profits get competed down to where it's breaking even. So the company's profit decreases. To be even more specific, we could say decreases to 0. D asks, in the long run, if the company continues to produce, will it produce the allocatively efficient level of output? Explain. So the answer is no. It should be easy to say. It's pretty much instinct to say that as long as it's not perfect competition, it's not going to be allocatively efficient or productively efficient. So it's not going to be allocatively efficient. The explanation is because price will still be greater than marginal cost. That's true in both short and long run in monopolistic competition. And last part of the problem here, E. In the long run, will the company be operating in a region where economies of scale exist? Explain. So the answer to that, probably best if we draw the graph so you can see it. Demand, marginal revenue, marginal cost, profit maximizing quantity and price. And remember, in the long run, our graph looks like this. You've got ATC tangent through there, and cutting through marginal cost at its minimum. So what we're looking at to answer this question is, this is where it's operating in the long run. Is that a region where economies of scale exist? Economies of scale, remember from our long run cost kind of situation, means that if you increase quantity, then increasing quantity leads to decreasing average total cost. You're getting more efficient to produce each unit. That's the definition of economies of scale. So is that the case here? Yes, if you increase quantity from here, you're moving downward along this average total cost curve until you hit this point. That's the minimum. So the answer is yes, because average total cost decreases to its minimum point where it crosses marginal cost. That's the answer there. Okay, hope this is helpful. I will not see you, as you know, during the quiz on Friday. Hope it goes well for everybody, and I look forward to seeing you next week on Monday.